All right, welcome to warm-up number 15. I'm going to factor this quadratic trinomial. So I'm looking for a common factor first. Nothing goes into all three of those terms though. Okay, so now I'm going to use a modified diamond problem. So since I can't factor this 3 out, I'm going to multiply it by the constant at the end. So then this will just become x squared at the beginning. Okay, and then 3 times negative 10 is negative 30. Okay, so now I'm going to set up a diamond problem to factor this trinomial, my new trinomial. Okay, I'm looking for two numbers that add to negative 13 and multiply to negative 30. Okay, and you can make a list of all the ways to multiply to get negative 30. So, you know, we would have to, one of these would have to be positive and one would be negative. So, you know, these might work, but nah, I can't get 13 out of those. How about 3 and 10? Oh, that's very promising, but remember one of them has to be positive and one has to be negative. So that doesn't work either. Okay, so let's try to think of another. How about 2 and 15? Ooh, this is promising as well. So 2 and 15, if one's positive and one's negative, there's my winning combo right there. 2 and negative 15. Okay. So then this is going to factor into x plus 2 times x minus 15. Okay. And since I modified the original trinomial, now I got to modify the factored version. So in the beginning I multiplied by 3. Now I'm going to divide just the number parts by 3, just the constants. Okay, and then I will reduce these as much as I can. If I had 4/6, I would reduce it to 2/3. These are both actually already reduced, so I can't, well, no they're not. 15 over 3 is 5, so this reduces into just negative 5. Okay, but I can't reduce the 2/3, so I'm going to take the denominator and pull it out in front of the x. And then that 2 is just going to fall to the ground, and this is factored. And I'm kind of just spot checking my factored version, making sure there's no more factoring I can do. There's no common factors. Sometimes that'll happen if you missed a common factor at the beginning. Okay, all right, and then we've got a word problem. I love word problems. Don't you love word problems? That's nice. I thought you did. Okay, so we've got a projectile. It's modeled by this quadratic function, and just looking at this, the squared term is negative, so this is going to open downwards, which would make sense for a projectile, right? Something getting shot out of a cannon or something, and then falling back down to the ground. So it's going to look something like that. Okay. So, when will the projectile... Oh, I've got a typo on here. I will fix this on the linked version, but this should be positive 48t. Okay, so let's figure this out. Okay, so t is time in seconds and h is height in feet. When will the projectile reach its maximum height? Okay, so I'm going to draw a little picture down here of my projectile. It's going to reach its maximum height right there at the vertex, right? So this is going to be an x-y pair. So the x pair would be the time, and the y pair, the y coordinate, I should say, would be the height. Just looking at the way this is set up, in h of t, that means t is the input. T is like the x value, right? And h is like the y value, okay? So this is saying when, so I'm looking for the time. I'm looking for the x value then, or the t value of the vertex. And I can find that because it's going to be on the axis of symmetry. So I'll just use the axis of symmetry formula, which is usually x equals negative b over 2a. And it still is, except I've got t instead. So t is going to equal negative b over 2a. Okay, so my b here is going to be 48, and my a is going to be negative 16. Okay, so then I've got negative 48 over negative 32. okay? And that's a negative over a negative is going to be positive, and this is going to reduce to 3/2, which is 1.5. And we're talking about when, this is time, and I know that time is in seconds, so on these word problems, you always want your units. So that's going to reach its highest point at 1.5 seconds. Okay, so I'll just put that in my little picture over there, okay? What is the maximum height? So then I'm asking for the h value, right? So I need the h value at the vertex. So let's go ahead and find it. Now I already know that it's going to reach its maximum height at 1.5 seconds. So that means I'm just going to input 1.5 in for t and see what h goes with it. Okay, and I'm just going to simplify these terms one by one. So let's see, 1.5 squared, and then I'll multiply that by negative 16. That's going to give me negative 36. And then 48 times 1.5 comes out to 72. Plus 160, okay, and then I'll do the addition. And this is going to come out to 196, and this is my height. My height is in feet, so 196 feet. Okay. All right, and then the last part of this, when will the projectile reach the ground? So it's going to reach the ground. I know what the height is going to be when it reaches the ground. The height is going to be 0. So my question is, what is the time? This is when. So I'm looking for the t value down here. Okay. So and you know, there's actually another place where it would be at a height of 0, which would be over here. So I might get two different t values. Okay, but I'm going to be plugging in 0 for the y coordinate here, which is the height. So I'm going to put 0 in for h of t. So 0 is going to equal negative 16t squared plus 48t plus 160. Okay. All right. So looking at this, I'm going to want to solve this for t. So it might be nice to factor this. Okay. Now I also want to look for a common factor right off the bat. So I'm looking at these and I know they're all even numbers. So at a minimum, 2 goes into everything. But I'm just going to check to see if maybe 4 goes into everything. I know 4 goes into 16 and 4 goes into 48. Actually, 4 is going to go into 162 because 4 times 4 is 16, right? All right, well, let's see if 8 goes into everything. Well, it'll go into both of those. It'll actually go into 160 as well. So let's keep going. Let's see if we can get, maybe 16 goes into everything. I know 16 goes into itself. Let's see if it goes into 48. It does. And let's see if it goes, well, 16 obviously is going to go into 160. Okay. So I could factor out a 16. That would be fine. I'm going to actually factor out negative 16. Just so that my t squared term is going to be positive. I always like to have the trinomials start with a positive x squared or t squared or whatever, if possible. So I'm dividing 48 by negative 16. That's going to give me negative 3, so negative 3t. And then when I divide 160 by negative 16, that's negative 10. Okay? So I've factored out the greatest common factor. You could actually also just divide the whole equation by negative 16 and it would look like this, and that'll lead you to the same thing. Because I'm going to factor the remaining trinomial, it will look like this. And then I'll use zero product property, but negative 16 can't equal 0. It just doesn't equal 0, so it's only these two factors are going to lead me to solutions. Okay, so let's factor this remaining trinomial then. Okay, adding two numbers to get negative 3, multiplying the same two numbers to get negative 10. Well, how about 2 and negative 5? That is the winning combo there. Okay, and now I can use zero product property. Well, that can't equal 0, so it's got to be one of those two. Okay, so I got those two t values. When will the projectile hit the ground? So let's think about if these make sense. Now, it's saying it hits the ground at 5 seconds. Well, sure, if it gets to the top of its route at 1.5 seconds, it would make sense that it would get to hit the ground maybe at 5 seconds. So this is a legitimate answer. Okay? But then it's saying it's also going to hit the ground at -2 seconds. Well, the problem with that is that we can't go back in time. It doesn't work that way, not yet, at least. So, yeah, this doesn't make sense, so I'm not going to use this for my answer here. Okay, now the reason that this could happen, that we got -2, maybe the projectile was shot from a cliff or something, right? You got like a balloon launcher or something, and you're shooting it from a cliff. So maybe your time 0 is somewhere here. So you'd have to go back in time and then back into the cliff to get to a height of 0. But maybe that could be the explanation for that. But this is the, we're not going to go backwards in time for our answers, right? Okay, so that's it for this warm-up. See you next time.